So today we're doing this. Friday, we're finishing up the last section. Monday's review. Wednesday is the final exam, and then we will be done after that. Okay. Do I have 2 monitors? Of course. Of course. Your quiz today is going to be on 10.2. Law of cosines only for your quiz today. All right. Any other questions before we get started of sort of what's happening, what the end of the class is going to look like? Yeah, so the last 2 homework assignments will be due on the same day as the final, 10.3 and 10.5. Those are just going to be normal homework assignments. And if you get a 80% on this quiz, then you'll get guaranteed credit on these ones. Just the same way that things have been going before. Yeah, 3 lowest quiz scores still getting dropped, for sure. That will be done after your quiz today, because after your quiz today, you will have taken all of your quizzes. Good questions. More questions. Send them on. Well, I said today. I don't know if I'll get to grading your quizzes today. I'll grade your quizzes tomorrow at the latest, though. Okay. The nice thing about 2 monitors, so there's so many advantages to 2 monitors, but you can even, there's so many like super cheap, tiny monitors that you may as well, like, that are like super easy to get, and they don't have to be nice monitors to still be useful as a second one. Yeah, so this is the homework, Ashton. So I don't exactly know what your question is. You have 10.2 due today, and then you have 10.3 and 10.5 due next week. And there's just a homework assignment over every single section we talk about. Eventually, I kind of want 3 monitors, but I have a standing desk, and it would get kind of cramped if I put 3 monitors up here. And that seems a little over the top, even for me. There's very few times when I feel like 2 monitors aren't enough. The only time 3 would be good is when I was streaming. Because on my second monitor, this is what I see on my second monitor. All the streaming stuff that I need to be aware of. But sometimes I want a second monitor in addition to that. Anyway, that's neither here nor there. Let's talk about math. Okay? So we're finishing up polar coordinates today. We're converting between polar and Cartesian coordinates for points. Now we're going to convert between polar and Cartesian coordinates for equations. Okay, so recall, right? These are the important things. Just like before, x is equal to r cosine theta. We use this formula a lot when we dealt with unit circles, right? On the unit circle, if we were trying to find sine of 90 degrees, for example, we could just look at the unit circle and say sine is the y coordinate, and say, okay, sine of 90 degrees is 1. Right? More generally, right, on the unit circle, the radius is 1, but more generally, y is going to be the radius times the sine of that theta. Okay? And then the other big thing that we're kind of using is the Pythagorean theorem, x squared plus y squared equals r squared. These are the big things that you're going to want to remember for this section. For converting between polar and rectangular or Cartesian coordinates. Cartesian, rectangular, we use those words interchangeably here. Okay? So those are the big ones. So now we're just going to convert some equations and kind of see what they look like. Okay? Convert from Cartesian to polar or vice versa, depending on how the problem is stated. So part A, x squared plus y squared equals 9. Hopefully, well, it doesn't matter too much if you don't, but it'd be good if you understood or recognized what equation this is. This is the equation of a circle. It's not a function. It fails a vertical line test. You can also tell it's not a function because there's a y squared right here. So one input can have multiple outputs. Okay, so a lot of things to kind of think about and see and all tie together when you see a problem like this. All right, but we want to convert it to polar coordinates. And there's a short way to do this and a long way to do this, right? This will always work to convert to polar coordinates. These two will always work. This third one will just make things a little bit faster. So x squared plus y squared, we said that's r squared, right? So we're just going to substitute that on the left. We're going to get r squared is equal to 9. Oh man, now there's a lawnmower. It's probably a lot louder for me than it is for you guys though, so I'll just try to ignore it. So this is our answer. This is our answer in polar coordinates. Okay? You could also rewrite this answer hold on. Hold on, I'm losing my mind. Let's graph this. Let's graph this. I just talked about like 5 minutes ago how I feel about sounds. All right, I can survive today. Is my window shut? No, it should be. It's so hot though. It's so hot. I can control myself. I can control my my anger. So let's look at this, right? X squared plus y squared equals 9. Whoa. That's the equation of a circle. We can also write this in polar coordinates, right? R squared is equal to, oh, wait, polar coordinates are not, polar coordinates actually only work on Desmos with theta, I guess. Okay, but yeah. You could also write this as r equals plus or minus the square root of 9, which is 3. Okay. All the points where your radius is 3, or all the points where your radius is negative 3. Okay. I will accept this answer. I will accept this answer. Or I will accept this answer. So notice, if it gets really bad, I'll close my window. But there's not that much lawn to mow outside of my window, right? Hold on, let me check. Yeah, there's not that much. So all 3 of these answers are okay. I will give full points for all of these. So you do need the plus or minus when you take the square root of both sides. You do need the plus or minus, but remember, what does a negative radius mean? Okay. A negative radius, when we were graphing polar equations, just meant go the other way. So let's look at this again on the graphing perspective, just to show why this is the case. All the points with a radius of 3. These are all the points with a radius of negative 3. Well, all the points with a radius of negative 3 are these same points. Right? So it's redundant to have that plus or minus there. But I won't take off points. I'll take any of these answers. Okay, let's do part B. X squared plus y squared equals 6y. So again, this is going to be a very similar problem, but not the same. So just like last time, we want to convert all of this to r's and theta. Okay. So again, just like before, this left-hand side, that's just r squared. So we're left with r squared is equal to 6 times y. But we don't want y's. We need to convert the y out. So again, just like before, right? These are the three things you need to remember. Y is r times sine theta. All right. And most of the time, not always, but most of the time, we want to solve for r. Okay. So be very careful here, though, when you solve for r, because we can't just divide both sides by r. If we divide both sides by r, that eliminates a solution. We can only divide both sides of an equation by something as long as it's not 0. But r might be 0. We don't know. So this is a quadratic equation. Okay? This is a quadratic equation. And we just subtract this over to the other side. There's really not much more lawn to mow. There can be. So let's subtract it over and get it in standard form. R squared minus 6r times the sine of theta is equal to 0. Actually, so fun fact, one of my favorite things about living in a place that's cold is for like 8 months out of the year, there's no lawn mowing. Like nobody mows their lawn in February here. Or at least I've never seen it, because you got snow on the lawn, right? Isn't that just wonderful? I hate sounds of yard work. Oh my goodness. Anyway, this is going to turn into a complaining stream real quickly. No complaining classes. So now we just factor the r. All right. Remember how we solve quadratic equations? We can factor. We can use quadratic formula. There's a whole lot of ways. We're going to factor here. Factor an r out, and we're left with r minus 6 sine theta equals 0. And this has two solutions. R equals 0, and r minus 6 sine theta equals 0. So again, moving this one over, the second one becomes r equals 6 sine theta. So these are both parts of the equation. And again, I will accept both parts of the equation. But just like in the first one, this first part is redundant. This is redundant because this solution, this part of the equation is included here. For example, if theta is 0, we get sine of 0, r is equal to 0. So it's redundant. So the best answer is just answering r equals 6 sine theta. All right, so let's check our answers. It's a really good idea to get into the habit of checking your answers when you're doing these. Let's see what this looks like. So in Cartesian equations, we have x squared plus y squared equals 6y. Okay, it's a circle that just got shifted up. Okay. What does it look like in polar coordinates? Does it look the same? R equals 6 sine theta. Yep. Same equation. All right, and you can really see that that r equals 0 part was redundant because it's included right here. This is when the radius equals 0. Okay, let's keep on going. Next, y equals 3x plus 2. This is the line. What does a line look like in polar coordinates? Well, let's just substitute it out. Y is r sine theta. X is r cosine theta. And we still have the plus 2. So just like before, we're trying to solve for r. So this is linear in terms of r, right? There's no r squareds, just r's. So we get all the r's on the same side and everything else on the other side. So we need to subtract this over. We get r sine theta minus 3r cosine theta is equal to 2. Factor out the r. We're left with sine theta minus 3 cosine theta inside. And then we can solve for r by dividing by this coefficient. Okay, so we're getting r is equal to 2 divided by the sine of theta minus 3 times the cosine of theta is our answer. And so you're really starting to be able to see, I think, that in some equations, it's a lot easier to express them in Cartesian coordinates, right? A line, y equals 3x plus 2, looks a lot better than the polar form of the line, 2 divided by sine theta minus 3 cosine theta, right? But in part A, for example, a circle looks a lot simpler in polar coordinates than it does in Cartesian coordinates, okay? So let's check our answer on this one. Make sure that we did it right. Go on Desmos. Our line is y equals 3x plus 2. That's what the line looks like. In polar coordinates, it's r is equal to 2 divided by sine of theta minus 3 cosine of theta. Good. See how the orange and the blue graphs are the same so that we know we did it right. All right, I don't know why I'm zooming in so much. So that's what's going on here. Okay. We'll just do more of these. Most of these earlier ones, going from Cartesian to polar, most of the difficulty is just solving for r and like your algebra skills. Can you solve quadratics? Can you solve linear equations that don't look like linear equations? Okay. Let's go the other direction. What if we're going from polar to Cartesian? R equals 2 secant of theta. Again, I don't really expect anyone to know what this looks like, but we're going to put it in Cartesian equation and see what we got. So again, these are the three things you want to use. X is r cosine theta, y is r sine theta, and x squared plus y squared is r squared. None of that's available to us right here. There's no substitution immediately available. There are some workarounds. But two things. One, in reciprocal functions usually are kind of annoying to deal with. So we could get rid of the reciprocal function. Two, we can also, if we wanted an r cosine theta, we could just make an r cosine theta. We can multiply both sides by cosine. In this case, those two things are the same, right? Secant is 1 over cosine. So we could also write it in this form, right? And then notice that if we multiply both sides by cosine, then we have r cosine, which we can turn into what we want. Let's multiply both sides by cosine of theta. Because now we have r cosine theta on the left, and the right-hand side is just 2. And remember, this is our definition for x. So it's kind of hard to see what situation we had in part D, but it's just a vertical line. X equals 2. Okay, so we check our answer. X equals 2, vertical line. In polar coordinates, this was r equals 2 times the secant of theta. Good. Same thing. Any questions so far? We got 2 more of these, and then we're going to introduce the next section very quickly, I guess, if we have time. R is equal to 3 divided by 1 minus 2 cosine of theta. So things are starting to get a little bit messier here. Okay. But again, if we get r cosine theta or r sine theta, we can plug those in for x or y. If we get an r squared, then we can plug that in for x squared plus y squared. Okay? But either way, a good trick, just like with reciprocal functions, is fractions and variables and fractions are usually not good. So if we multiply both sides of the equation by the LCD, we get rid of the fraction. So that's what we're going to do here. Multiply the right-hand side by 1 minus 2 cosine of theta. and multiply the left-hand side by 1 minus 2 cosine theta. So on the right-hand side, the fractions are going to cancel. Left-hand side, we can distribute. Okay. So when you distribute on the left, r times 1 is r, minus 2r cosine theta. Oh, good, that's going to be an x right there. On the right-hand side, the fractions cancel. We're just left with a 3. So we still have an r. Doesn't have a cosine. Doesn't have a sine. And we can't give it a cosine or a sine either. Okay. This is sort of a weird edge case that you might see. But let's replace this with an x, right? This r minus 2r cosine theta is x. So we're almost done. We're almost done. So what we can do is we could just square both sides. Okay. But squaring both sides right now is not very nice because then we have to square this whole binomial and we have to FOIL it, which is not what we want to do. Let's move that 2 over. We get r is equal to 2x plus 3. And now there's two things you can do here. You can just substitute for r. R is going to be the plus or minus square root of x squared plus y squared. Or you can square both sides. But remember, if you square both sides, you do need to square the whole side, not them individually. All right. And now again, we can use that final substitution. R squared, Pythagorean theorem, is x squared plus y squared. And the question is, do we have to solve for y here? And the answer is no, for a couple of reasons. One of the reasons why we don't have to solve for y is because it's not a function. We know it's not a function because there's a y squared right here. There's going to be multiple outputs for a single input. So it fails the vertical line test, fails the definition of a function. So we don't have to solve for y. There's actually a nicer form for this, a standard form for this shape. And you could manipulate it into that standard form, but we haven't talked about what shape this is yet. I'm not going to spoil it until we show it on the graph. So I will accept this as a final answer. So if it's a function, it's a good idea to solve for y. If it's not a function, you don't. Okay? Let me write that down. If function, solve for y. If not, don't. And then for polar, solve for r always. All right, just some guidelines. If you're ever uncertain on your final exam next week, I will make sure to be available on Discord. If you're taking the final exam and you're not sure, do I need to solve for y or can this be my final answer? Send me a message. I don't want doubt of that form during your final, okay? So please reach out. Okay. Let's do the last problem of the section and then maybe a short introduction, maybe not a short introduction. Let's see what this looks like, right? So in rectangular coordinates, well, let's start with, in rectangular coordinates, we said this was x squared plus y squared is equal to 2x plus 3 squared. In polar coordinates, we said this was r equals 3 divided by 1 minus 2 cosine of theta. So they're the same graph. This is a kind of a neat shape. It was always one of my favorite shapes. A hyperbola. Okay. It's kind of like bending a rubber band. Has diagonal asymptotes. See how they get very, very close to approaching a straight line. On the middle, it curves, just like if you're bending a rubber band. Okay. Or a string, or something like that. And these are two forms for a hyperbola. So let's do part F. Last part of the section. r equals sine 2 theta. So this is your lucky day. You're thinking, man, I really miss chapter 9. I get to review chapter 9 for the final exam next week, but I wish I could do it sooner. And that's what we're doing here. Because r cosine theta is x. Our sine of theta is y. But what about sine of 2 theta? We don't know anything about sine of 2 theta. We're going to have to use an identity. Tyler was not hoping that. Oh, breaks my heart. There are more equations, but there are more equations to make hyperbolas. The standard form for a hyperbola is x squared minus y squared equals r squared, which we almost had, but not quite. But I'm not going to make you put it in the standard form, because that would involve teaching you standard forms of every shape, which we're not going to do. So we need to use identity. So you could check your chapter 9 sheet. You will have your chapter 9 sheet available for the final. Or you could remember it, because I'm sure everyone loved double angle formulas. It's 2 sine of theta cosine of theta. Okay. And now we need to solve for this. And this is a more difficult substitute, right? Because we don't have an r squared, we don't have an r sine theta, and we don't have an r cosine theta. So I have to manipulate this a little bit, okay? So there's a lot of ways to kind of move this around, but maybe the most, I'm not sure what the most straightforward way is. Maybe the most straightforward way is let's get an r in front of the sine and an r in front of the cosine. Right? So if we multiply and put an r right here, right, that's multiplying an r on the right hand side. So we also have to multiply that r on the left hand side. Right? And now this right here is a y. But we also need to substitute this cosine of theta. So we have to multiply by another r, right? We have r squared is equal to 2y times the cosine of theta. We want an r here so that we can replace it with x. So again, we're going to multiply an r on the right hand side, multiply an r on the left hand side, and now this is x. So you have r cubed is equal to 2xy. And it's almost a nice situation. It's almost a nice situation, but it's an r cubed, not an r squared. So this is, again, sort of the worst case scenario to show you guys. Right? We know r squared is x squared plus y squared. So that means r, take the square root of both sides, is plus or minus x squared plus y squared. So what's r cubed? It's just if you cube both sides, right? And it's kind of messy. Okay. But that's what we're going to use here. The plus or minus can also come onto the outside. So you get plus or minus the square root. Wait, the square root cubed. There's a quicker way of writing that, right? Remember rational exponents? The 3 means it's cubed. The 2 on the denominator means square root. So a little bit nicer. And this is how we write it. So again, the question is, do we need to solve for y? Okay. Do we need to solve for y? And the answer is, if it's a function, solve for y. If it's not a function, don't solve for y. And it's definitely not a function, right? We have a plus or minus right here. We have a y squared. Definitely not a function. So you can write this as your final answer. So again, this is an example of something where the polar form is a lot nicer than the Cartesian form. And let's just check our answer and make sure that we're graphing the right thing. Okay. How do you add a plus or minus on Desmos, actually? I know, Nick, right? Maybe just plus or minus. There's a way to do it. R equals the sine of 2 theta. We got a cute little flower going on right here. In Cartesian, what does it look like? X squared plus y squared raised to the 3/2 equals 2xy, and the negative version of that. So it's plus or minus. So it does look the same. All right, and that's the end of the section. We don't have time to start the next section, and I don't think I have the mental state to start the next section. If you have any questions, you can ask them now. Otherwise, your quiz opens in like 3 minutes. So we'll finish the final section of the class on Friday. We may not finish it. We may have to finish it on Monday, but that'll be it. Good luck on your quiz.